Day 7, adding and subtracting rational expressions. Today you will be able to add and subtract rational expressions, and you will also be able to simplify complex fractions. Adding and subtracting rational expressions is similar to adding and subtracting fractions. To add or subtract fractions, you need to have like denominators. So when we add or subtract, on example 1, we're taking the quantity of x minus 3 over x plus 4 plus x minus 2 over x plus 4. They already have a common denominator, so we can write x minus 3 plus x minus 2 and put that all over the common denominator of x plus 4. Combined our like terms, and we have 2x minus 5 over x plus 4. On the subtraction problem, we need to make sure and distribute that negative to everything in this numerator of our second fraction. So we have 3x squared minus 5 minus the quantity of 2x squared minus 3x minus 2. The step of writing that in a parenthesis will save you and remind you that you need to distribute that negative to everything. So we get negative 2x squared plus 3x plus 2 over 3x minus 1, combined our like terms, and we get x squared plus 3x minus 3 all over 3x minus 1. X squared plus 3x minus 3 is not factorable, so we are finished. To add or subtract rational expressions with unlike denominators, you need to first find the least common denominator. The least common denominator is the least common multiple of the polynomials in the denominator. You can always find a common denominator of two rational expressions by multiplying the denominators. However, when you see the least common denominator, simplifying your answer may take fewer steps. Find the least common multiple for each pair. So when we talk about a multiple, we want the numbers that are bigger than 6 and 4. So 8, 12, and when we list the multiples of 6, we can see that we quickly found the least common multiple between 4 and 6 is 12. The least common multiple between x squared and x to the 4th is x to the 4th, so you're looking for the bigger one out of the two, and we would have y to the 5th. When we look at x squared minus 2x minus 3 and x squared minus x minus 6, we want to make sure and factor those. So factored, we get x minus 3x plus 1, x minus 3, x plus 2, and we want to look for what's missing. So they both have an x minus 3, but we can see we have an x plus 1 in our first one and x plus 2 in our second one. So our common denominator would be x minus 3, x plus 1, and x plus 2. So you want to take what each piece has and make it 1. To add rational expressions with unlike denominators, you want to rewrite both expressions using the least common denominator, and then the process is very similar to adding fractions. So you can see in this simplified version with fractions, they found the common denominator of 30, and then they combined their like terms and got 19 over 30. With rational expressions, in example 5, we have the quantity of x minus 3 over x squared plus 3x minus 4, and we want to add that to 2x over x plus 4. So the first thing we need to do is we need to factor our denominator. And when we factor our denominator, we get x minus 4, x plus 4, x minus 1. So we can see that this denominator over here has an x plus 4, has an x plus 4, but it's missing an x minus 1. So our common denominator, we want to multiply by x minus 1. on the right hand side. So we found the missing pieces, missing denominators, and we multiplied by those. So in our first fraction, it's going to stay the same, x minus 3. In our second fraction, we need to distribute our 2x to our x minus 1, so we get 2x squared minus 2x, and our common denominator is x plus 4, x minus 1. We need to, so our third step was to distribute. Our fourth step is going to be to combine or distribute and combine like terms, and then we're going to need to factor the numerator again. So when we combined our like terms, we get 2x squared minus x minus 3 over the quantity of x plus 4, x minus 1. When we factor that, we get 2x minus 3 times x plus 1. X plus 4, x minus 1 remains the same. There's nothing that cancels, so we are finished. Example number 6, step number 1 is to factor the denominators. We have a 2 in common between 2x and negative 2, so if we factor out a 2, we're left with 2 times the quantity of x minus 1. Factor out a 3, we're left with x minus 1. They both have an x minus 1 in common. This one, the right hand side has a 3, the left hand side has a 2. So we need to multiply by 2 on our right hand side. The left hand side was missing a 3, so we need to multiply everything by 3. So we have 9x plus 6x minus 4 all over 6 times x minus 1. When we combined our like terms in the numerator, we get 15x minus 4 over 6 times x minus 1. There's no common factors, so we're finished. Looking at the next one, the very first step is to factor the denominator. Remember, you're only factoring the denominators because you're looking for what the other ratio or side is missing. So you can see that they both have an x plus 3, but we're missing an x minus 3 on this side, so we need to multiply both the top and the bottom by x minus 3. So we have 2x squared minus 30 over x squared minus 9. We have, when we distribute this out, x times x is x squared minus 3x plus 5x minus 15 all over x plus 3, x minus 3. We want to distribute our negative to everything. So when we combined our like terms and distribute our negative, we get negative x squared minus 2x plus 15. X squared minus 2x minus 15 is our new numerator. So we want to put that x squared minus 2x minus 15 over our common denominator, which is x plus 3, x minus 3 factored. We want to factor our numerator, which factors to x plus 3, x minus 5. We can simplify because we have an x plus 3 in the numerator, x plus 3 in the denominator. So our final answer is x minus 5 over x minus 3. When we look at example 8, we want to factor factor your denominators to see what each is missing. So we have x minus 3, x minus 1. You can see they both have an x minus 1 in common. This one has a 2, this one's missing a 2. So we want to multiply the numerator and the denominator by 2. This one has an x minus 3, this one's missing an x minus 3. When we distribute all of that out, we should get x squared plus 2x minus 3x minus 6. We're subtracting, so we want to put everything in this numerator in parentheses, negative 4x minus 2. Combined our like terms. We get x squared plus 3x minus 4. That is our new numerator. Put that over our common denominator, which was 2 times the quantity of x minus 3, x minus 1. Factor our numerator, x plus 4, x minus 1. Cancel out what we have in common, so we can get rid of an x minus 1, and we have the quantity of x plus 4 over 2 times the quantity of x minus 3. Some rational expressions are complex, so we have addition in the numerator or division or something additional in the denominator. So we just want to remember that this bar right here means division. And when we divide fractions, we multiply by the reciprocal. So if we have something like example 9, we can put x plus 1 over x squared minus 1. Change that to multiplication and multiply by the reciprocal. We're going to factor x minus 1, x plus 1. We can then simplify, so x plus 1, x plus 1, x minus 1, x minus 1. Remember, when you get rid of everything in the numerator, leave a 1 there, and you're finished. Looking at the next one, we'll have to find a common denominator in the numerator, so we need to multiply this side by 2. So we have 2 plus 1 over 2x. So 3 over 2x, we multiply by the reciprocal. So we have 3 times the quantity of x minus 2, 2x times the quantity of x plus 4, and we are finished.